Welcome back to Module 2 of our velocity-based training series brought to you by GymAware. In this module, we're going to be talking about key concepts in load prescription. Now, when we talk about load prescription, in particular on the gym floor, in that athletic performance space, we kind of already know the key metrics and variables that we can use. We've got rest, sets, tempo, reps, and obviously load. Now, within that, we tend to be quite restricted around how we start to prescribe what we would deem velocity or power development. How do we know that we are moving a load fast enough to elicit enough power output or enough velocity for us to be able to see some sort of translation or bleeding of that into the sport that we want to actually affect? Hence, we now look at velocity-based training, and I alluded to it in Module 1. So when we look at velocity-based training in its basic form, it simply allows us to track the velocity of movement, but then also allows us to be prescriptive with that velocity. Now, when we start to talk about prescribing velocity, no doubt you've probably heard of some key velocity bands, some simple bands we can see up here, where we have starting strength sitting above 1.3 meters a second. Speed strength sits between that 1 to 1.3 meters a second. Strength speed between 0.75 and 1 meter a second. What we'd term accelerative strength between 0.5 and 0.75, or what we would deem absolute strength, which is typically below that 0.5 meters a second. Now, when we look at these velocity bands, it's easy to name them, see them, a lot harder to really understand the outcome that we're getting with them. And what we want to look at is how do we, in the simplest form, start to utilize these bands and these speeds to start to prescribe some really good velocities for our athletes. Now, we're going to delve in a little bit deeper in a separate module around it, but we want to start to look at how we have our bookends of speed versus our mid-range of velocity and what we want to try and target. Now, when I say bookends, we can refer to that as, say, max force. So if we're chasing maximum force or absolute strength, which we can see is sort of below that 0.5 meters a second, I think we can all see and look at an individual and know, yep, that's a 1 RM or a 2 RM. It's moving slowly, it's heavy weight. That's our maximum force end. We've bookend that and we're pretty confident with that. When we're talking about this top end, or what's technically that starting strength, but high velocity movements, these are things like jumping, where we have quick contact times, high speed of movement, typically low or no weight whatsoever, where we can move as fast as we can. That would be our other bookend. We can see that high speed and high force, or at least high load, are fairly easy to ascertain. We can establish that pretty simply. And to be honest, as strength and conditioning coaches, that's what we've been very good at. What lies in the middle becomes a little bit harder. And how do we manipulate the middle by allowing us to utilize a velocity prescription is exactly what we want to try and learn over the next few modules. Now, as I've said, at the basic crux of velocity-based training, it is simply a way to prescribe another variable. And one of the key ways to do that is to simply use the velocity prescription without using a load prescription. As soon as we use a load, we then start to manipulate what the velocity is going to be. The load will control the velocity, not the velocity controlling the load. So one of the simplest ways that I use it with my athletes is to look at, okay, if I want to prescribe a velocity, then I'm actually not concerned about the load for this set, rep, or exercise. So I may select something like a strength speed or a speed strength, that middle ground, where I want to maybe be always above 1 meter a second, but I don't want to go any faster than 1.2. Because I know if we're going at 1.2, we're starting to dip into that high speed, low load area. I actually want my athletes moving with a little bit of grunt, slightly slower to potentially extend the contact time to be able to produce more force under velocity. Therefore, I'm going to select between 1 and 1.2 meters a second, and what they then select for their loading is up to them, as long as we are achieving a really good velocity based within the band that I've given. Now, simply using that allows us to use velocity, or at least VBT, for another prescriptive variable that allows us to have a really good transfer to sporting environments and allowing us to create velocities and speeds that potentially mimic some of the outcomes that we need in that environment. The next question then becomes, well, what variable can I use? Because when we talk about velocity-based training, velocity is not the only variable that has the option to be recorded. And it's really important to understand, especially with the GymAware units, that there is quite a few variables that we can use. So understanding when we use it and why we use it can be quite powerful. And yes, there's going to be some very complex individuals and reasons to use specific metrics, but to keep it simple, to keep it practical for the gym floor, a couple of the key variables that we use and why we use them, I'm going to go through with you right now. So if we look at the recording, we can see the app setup. We can see what it looks like. If I'm clicking on the variables, you can see the first two that I have is a height and a dip. So ultimately, this can be used when we start to do counter movement jumps or squat jump options, where you may have the tether attached to a belt, you may have it attached to a dowel rod. Now, because of that, it's a weightless type jump. It's exactly the same as what you might do on a force plate, but it allows you to be a little bit more practical with travel, and obviously from a pricing standpoint, it's a little bit cheaper. But we want to make sure is when we're measuring variables that they're going to be contextual to the individual and what we want in the outcome. We want to understand how high that individual gets. It's a really good measure that we can track over time for counter movement jumps or squat jumps. The next variable that we see within this is dip. So we can see what type of eccentric distance was traveled to produce the height that was achieved. So we may want to look at athletes that create a stiffer jump, i.e. not taking up as much muscle slack with depth. They need to be quicker. Something like a basketballer or a netballer that sits under a ring or a hoop needs to get up quickly. So having all this time where they dip down to then drive up is counterintuitive. Really important to see how we can improve that dip. The next variables you'll start to see are mean power and peak power, both obviously ascertained through watts. So when we look at power, that is taking into account the load that's being lifted along with the velocity that's being lifted as well. So the two options there you will see with it is, okay, well, we want to understand where an individual is most powerful. Some individuals are really good at lifting large loads. Other individuals are very good at lifting with high velocity. But we want to understand across a group or a team, where do we start to see the maximum power output and try and shift that power so those people that are very strong as individuals may be able to move a little bit quicker, and those people that are very fast as individuals may be able to move a little bit more load with that same speed. So when we have those two comparisons, we have the options here as a mean power or a peak power option. Now this carries over to the velocity side as well. If I'm looking at mean power smooths out each of those reps, each of those sets. As an example, if I have a bar moving in a bar path and there is a slight acceleration or higher velocity moment from my thigh hitting it, something bouncing off it, me changing an angle, you will see in peak power, this gets picked up. So it'll spike and that will be the peak power reading when you see it on the output. If I put it as a mean power, meaning the average of the entire movement, it will smooth out and allow for any of those little peaks to be smoothed out and give me a greater indicator of what the entire rep looked like for power output. So that's why I'd use mean power versus peak power when in some instances, for example, if we're using maybe an overhead jerk, something like that, very rarely will there be an option to cheat by bumping the bar or slaying the bar across a different bar path, in which case using peak power can be really efficient there to allow us to get a true indicator of the maximum power that was achieved in that movement. If I keep moving down the list here, you can see I now move to mean power and peak power relative to body weight. So now we can take those raw results, but I can now even it out and distribute it across an entire team to get some really good relative indicators of how they're moving based on their body weight, both from a velocity standpoint and a power standpoint. If we keep going, we've got mean and peak power into mean and peak velocity. The exact same outcomes apply as I spoke about before. When we're tracking just velocity, we're not accounting for the load on the bar now. So we are just using velocity as a standalone variable. Like we spoke about, it may be a really great variable to use where you don't actually prescribe the load. You just prescribe the velocity band that needs to be hit, and the load will take care of itself based on how that individual is going for that day. Now, within those two variables, we have, again, mean velocity and peak velocity. Mean velocity, I would typically use when I want to make sure that each rep is smoothed out and I'm not seeing a peak or some outlier of velocity based on an inaccurate movement of the bar or an accessory movement of, say, a hip hitting the bar that may potentially speed that bar up just for a brief moment. I.e., if I'm using Olympic lifting, sometimes you can cheat and get a little bit of a bump on the bar. But when we're using peak velocity, in exact same way for peak power, this now gives us the true maximum speed that was achieved, instantaneous speed in that moment throughout that lift. So things like a basic squat, potentially a jerk, where there's less likelihood of these inaccuracies being caused, could be a really good spot to start with peak velocity. We then can see we have concentric time and eccentric time. So we can start to measure and look at how long does it take an individual to prepare by eccentrically loading their joints and muscles, but then also how long concentrically does it take for the individual to either gain flight or achieve the movement. Both of these options can be really valuable when looking at how someone actually produces force and how they produce power, but more importantly, potentially in a jump scenario, how are they achieving their maximum jump height? Is it with a short eccentric load and a longer concentric loading? Is it vice versa? Do we then use those ratios to group athletes in different programming structures to try and achieve the outcomes based on their results, rather than just a general cohort overview of one program all trying to improve velocity? And finally, you can see here eccentric mean velocity and eccentric peak velocity. So very similar to the fact that we can look at eccentric time, we can also look at the velocity at which is reached during the eccentric movement in preparation to create the force outcome that's needed for concentric return. So it can be very effective in rehab, and we'll talk a little bit more about that in our rehab module, but also really interesting to look at how your athletes will achieve eccentric velocity to be able to take up muscle slack in a lot of the power output performances that we'll see in jumps and Olympic lifting. Now, there's a lot of variables there to use. That doesn't mean that we use all the variables and all the time. There will be a couple of key ones that I will always favor, and I'll talk you through them as we go through the modules. But it's important to understand the context of the athlete, the outcome, and the scenario to really understand why you're going to use those variables and when to use them. Now, with GymAware, it's beautiful because it collects it all anyway. So if you ever want to go back and look at these variables at a different time, they're always there. But when we select what variables for the athlete to focus on as direct feedback becomes very important for us. So making sure we select the right one for the right lift and the right outcome gives a really good foundation for that athlete to improve performance and focus on the right things to get better.